Welcome to the ESD Essentials video series, which will cover the fundamentals of electrostatic discharge protection. In today's video, we will cover the clamping voltage of an ESD diode and why this is a crucial parameter in understanding how well an ESD diode will protect system circuitry. This video is the fourth entry in a 6-part video series. You can find these videos and more at ti.com/ESD. In the last video, we covered the IEC 61000-4-2 rating and how it quantifies the robustness of the ESD diode itself. However, one common misconception is that the IEC rating of the diode guarantees protection of the entire system up to that IEC level, 8 kV, 15 kV for example. In reality, the IEC rating only shows what the diode itself will survive, while the clamping voltage of the diode will quantify what voltage system circuitry will be exposed to. Remember that an ESD diode is placed in parallel with the protected circuitry, so the clamping voltage is the voltage that will be dropped across both the diode and the downstream circuitry. Here is a plot in the time domain that shows an 8 kV IEC strike that is discharged into a system. This red waveform is what the system would be exposed to if there were no ESD diode present. However, once this strike enters the system, the ESD diode will immediately break down and provide a low impedance path to steer the majority of the ESD current to ground. However, since there is some resistance in the diode, there will be a clamping voltage, which will be what the protected circuitry will be exposed to. This blue waveform shows the resulting clamped waveform. The best way to find the clamping voltage of an ESD diode is to look for the transmission line pulse plot, or TLP plot. The TLP provides the current voltage relationship of the diode, and the clamping voltage can be extrapolated for a given input current. For example, when 1 amp is discharged into the diode will clamp at 8.4 volts. When 2.7 amps is discharged, the clamping voltage will be 9 volts. At 5.8 amps, it will be 10 volts, and so on and so forth. In a future video, we'll go over this in more detail, but to estimate the clamping voltage during an 8 kV IEC strike, we need to look at the voltage response at 16 amps. For this diode, the clamping voltage is about 13.4 volts. The slope of the TLP curve is important in understanding how well the diode protects. For example, this other diode shown by the green curve has a sharper slope, and as a result, it has a lower clamping voltage for each given current. By Ohm's law, the slope of these curves is 1 over R dynamic, so next time you select an ESD diode, look for one that minimizes R dynamic to provide a better clamping voltage. Thank you for watching. To keep learning about ESD, watch our next video on parasitic capacitance. For more details on ESD in general, go to ti.com/ESD.